Okay, so our next speaker, I will introduce him here. So, so our next speaker will be Bala Manikandan. Kandan. Actually, I'm sorry about that. Maybe you can pronounce it by yourself later. So Bala actually working on a research that is using similar technology and technique and method that we consider heuristic, trying to use neural networks to in the Python to detect the falling situation. So as you can know that if elders they live inside a house by themselves, when they are falling because they are old, so sometimes it will be better to have some kind of a mobile app to calling for the help or calling the relative to check in, something like that. So that is our goal. Of course, there are so many fall detections research out there. So what is our benefit or advantage? Bala will talk to you. So let's welcome Bala.
Thank you, sir. Thank you for inviting me and welcome everyone. Thanks for having your time for our research work. Let me share my screen. So, hello, everyone. I'm Bala Manikandan. I'm doing my MTech in Amrita University in India. So I'm doing this research of fall detection where we eliminate the environment and different environment and only look into the trace of the person and to predict like whether they is falling or not like that. So I'm doing this project under the guidance of Professor Mayang and Professor Sendil Kumar from my college. And our research agenda is actually, as Professor Mayank said, like we are detecting the fall of a person, like when the elders are alone in the home, and like we are recognizing the actions of those persons, whether they are lying down or sitting or like other activities, and also we are differentiating from the fall activity. So there are many approaches out there for fall detection, but what we are focusing is to reduce the latency and the prediction time. So how quickly we predict the fall of a person. So to predict the fall of a person quickly, we have to reduce the all the processing constraints. So we are developing, yeah, or algorithm or architecture that that takes very less time, less time to predict the fall of a person. Uh, like since to for reducing the processing power, we are like as we said, we are looking into the motion trace of the person and extracting uh, the trace of the person to predict whether the person is falling. So our intuition comes from the dynamic time warping algorithm. So as you can see the like in the right side corner the gif. So every object or every person has some sequence in a sequence of actions. So this in this gif, like we are two persons are walking. It is like even the person, one person is walking faster and one person is walking slower. We can see that the it follows the same pattern. So for walking, it follows the every person mostly the pattern, walking pattern will be similar. So that was the intuition behind our approach. And we have two reasons. Like the first reason is like the since only we are focusing on the movement trace alone, it reduces the processing time and for the prediction of the falling. And also it since it eliminates the environmental context, uh, it can generalize in any environment. like say for example, if we are training the model neural network model in one environment, like we can use it to another animal, for example hospital or something like that, a completely different environment. So that was the approach we are looking into it. And the we actually worked on two different data sets. Both are open source data sets. And the first data set was your fall detection data set. So it has totally 70 videos, and of yeah, 30 in which 30 videos are like fall sequences, and 40 videos are like different sequences, like tying shoelace or sitting down in a chair or sleeping in a bed, like that. So they used one Kinect camera, and there were three subjects in that in all the 70 videos, like different in different videos, different subjects. So if in both the data sets are actually it's like only one person will be available in the throughout the video. First we are looking into a video, classifying the video which consists of one subject. So both the dataset consists of only one person in the video. And the second dataset is little bit advanced, so it has something around 383 videos of multiple action sequences, like all some 12 action sequences. So they also used one Kinect camera, and there was 50 acting subjects who acted in all those videos. So the reason we started from your fall detection, which is 70 videos. So the reason why we started from your fall detection is like a basic data set is like we will first develop a model in your fall detection. Then we will it is actually less data, very less data compared to the CMD fall data set. We wanted to test our intuition, like incremental learning approach. We started with the UR fault detection dataset, and we'll try to see how the model generalizes better in the bigger dataset. So that was the intuition. So we started from UR fault detection dataset. So next in our project workflow, there are three stages. And first stage is like preparing data. Like there are two ways the way from where the data can arrive. Like one is the actual data set from the cloud, stored in the cloud. Where we used it for training and building the approach, neural network approach. And one more thing is like during the prediction sequence, like maybe a video from CCTV camera, like monitoring the home or something like that. So first we take the data, I mean video, and extract the frames of the video. Then we will actually randomly select some of the frames, like we will bucket the frames, and we'll try to use our algorithm on each bucket to predict whether the person is falling or not. So the stage two consists of algorithm part. Like we extract the movement trace from the video. The stage two consists of the two parts. One is the structural similarity, like when we when like structural similarity, like we will differentiate the each frame, subsequent frames, to extract the motion of the person in the video. And after that we will draw the bounding box around the motion, I mean where the motion happened. So then we will extract the trace by using the center points of that bounding box. So the stage three consists of the deep learning part, where actually where actually like we will use that motion, extracted motion trace image, and pass it through the neural network to predict whether the fall of a person. This was the process pipeline. So from the cloud, I'll be like we will download the data set and store the raw videos in this videos folder. And like a video in this video folder, we can say like different videos with a different names. And after that we will use let me see, like we will use Python file to extract the random frames from the videos to for the training process and all. So that will be we will be stored in the subset, a subset folder, and where like we will have a three like structure to have like a video name folder and different frames like a sequence of frames like. We tried approaches from 20 different number of frames. So the for example, if the it is a 50 frames, this folder will consist of 50 frames. And next after that we will come to the second stage, where we extract the bounding box like we I'll come back in a minute to say about the bounding box extraction. Where we'll try to find the motion pixels in the image and store it in the bounding box folder. Here also, like we use that video name and below that different frames of like 50 frames mostly. And after that, like it also creates the trajectories folder. So the final image, like once in bounding box folder we have 50 images, like for each image the each frame the bounding box will be calculated and plotted just to for a moderation purpose. And after that, in trajectories folder it will store the actual movement trace of the subject. So and the third stage consists of the neural network part, where we pass the trajectory image to the neural network for the prediction. So let me show you the code. This is the first stage. So I just download the dataset from the cloud where they stored the videos. These are the functions I wrote to download the zip files and extract the frames, and it will be stored in the data set like URFT. I have like I'll be storing the videos in the temp folder. So I in that cloud they stored it as a zip file. So after that I'll extract those zip file and store it all the frames the video contains in this frame folder. There are 70 videos. I'll be storing it in here, and then after that I'll be like um, for each folder I'll assign the label like whether it's fall or other activities, so that in the later stage it will be processed easily. I'll for each folder, if frame folder, I will assign the labels in here. Then after that I'll extract the random frames like here let's say the 50. So here if I say the clip length is 50, so it's like 50 frames I'll randomly extract. The video may contain something around 300 or 400 frames also. I'll extract random 50 frames, I mean the 50 sequence. Then after that I'll store it in the subset folder. Let me show you the subset folder. Yeah, okay. So I'll store it in the subset folder, and I'll be like already created the train and validation thing. So for each folder for each video I'll be creating the different folder of 50 frames each. So after that then I'll be using the data, like the second stage comes in. So like I'm using the structural similarity function. So it what it actually does is it like first we'll be using the difference between subsequent frames. So this is the formula for structural similarity, where it actually finds difference between the luminance and structure of those two frames. And once we find the difference between the two frames, and we can get the contour of that where the motion happens. So once I find the contours, I'm drawing the bounding box around that contour. So I'll get the bounding box of that most of the pixel where the motion happened. So I'm after that then I'll extract the center point of the bounding box and plot it in a black background image. So I'll just this function is to draw the trace of the points. So I'm extracting the center point of the bounding box, and I'm passing it to the line function so that I'll get the motion trace finally. So after the motion trace, I'll be storing that in the trajectories folder. So you can see that there are like in the black screen, I'll be like storing, I'll be drawing that motion trace of the for video. So these are the traces for fall videos, and like these are the traces for different other activities. So we can even differentiate much quickly. Like this is some like mostly the fall videos are similar, having a similar traces. So for documenting purpose, I like we stored those files in this folder. The motion trace also, as I said, I create a background image and draw the center points around that image. So next, this is my like overall approach. So the you can see that the videos may be coming from either cloud or some living area CCTV camera. So once I get the video, I randomly select different frames and extract the bounding box, then trace of the bound, I mean center points and trace of the movement of the subject. Then after that, I'll be passing it to the neural network, through which I can get the predicted output. I mean, whether it's fall or not. It's a binary classification problem. So I'm predicting whether it's fall or not. So all these approaches are I mean logged inside the logging tool. I'm using the open source WNB logging tool. So where actually, like, I can compare experiments with different I can write different experiments and see the graphs around it. So this was I use this logging tool to monitor the different approaches and performance analysis. So after that, the coming to the third stage, neural network part. So I used two blocks of, I mean we used very vanilla CNN, like very basic CNN to predict the output. So it it actually we decided on it based on the processing constraints. So even this neural network predicts well, given some better accuracy. So for example, we have a trajectories folder of content consisting of fall images and ADL activity, other activities. So we pass the data set, and I mean the newly processed trajectory data set will create will use train and validation for a training purpose. So basically it is like two blocks of one convolutional and pooling layers to extract the features of that image. There are different advantages for this approach. Like when we see this moment trace, it's like it is like there is no environment, so it can, the CNN can focus only on the movement of the subject in that line, in the whole image. So that was one of the advantage. And after that, even if we like this is for this data set is for as I told, it's a single person. So even if there are multiple persons, the trace will be like multiple traces will be there, and we can differentiate like the if the one of the traces are for a person is falling. And since we using the bounding box approach, we can localize the person who is falling, and we can intimate the neighbor or some caretaker. So that is for future use. And this is the uh, actual for neural network for prediction. So While I'll show you the demo before moving on to the thing. Just so this was one of the demos. So you can see that it is the running, the frames are running in there. It is actually 50 frames. So it is like it once the person moves the we can see that the trace is also drawing the trace. So like for falling person, this was the trace. So if I select some aerial activity, uh, so you will find like it is the person sitting in the bench. So we can find that traces are drawing over the right side image. So we can clearly differentiate between the fall and other activities here. So after this was the approach. So we only pass this right side image and to the training, I mean the training or neural network training. That actually after that, let me see the results. So we tried multiple approaches. One of them is 25 frames and 50 frames. Usually the CCTV camera will have for 25 frames per second. So we tried from starting from 25 frames, and also we tried for 50 frames. Then also like increasing the number of data samples. Also we tried the different approaches. We can see like in this graph, and the 25 frames is actually somewhat noisier. So one potential reason was since we are drawing the image, one second. We are drawing the trace. It is like that, since it is 25 frames, the trace might not fully drawn. Like it might not give a reasonable differentiation. So that's why the we can see that there are much noise. And in 50 frames, we 50 frame approach, we got around pretty good result. Like we got in the first URFT dataset, we got around 100%, and it is quite stable. And if you see the accuracy, it is it got reached around 100% accuracy in that URFT dataset. So for the processing time, it is around 2.4 seconds for 50 frames. To extract the 50 frames and calculating the movement trace, it is around 2.4 seconds. And for 25 frames, it was around 1.1 seconds. And for model, it is training time was around 1.25 seconds for per epoch. So it was around 5 minutes, less than 5 minutes for training the model for the whole data set. So the for the prediction time, it is almost less than 1 second. The main time barrier comes from the pre-processing time, where we use the algorithm part. So the for total time for prediction, whether prediction of whether the person is falling is something around 2.5 seconds. So yeah. So after that, we checked on the generalization capability of the model. So we completely introduced the very new dataset, the CMD fault dataset, where we checked, like we use the pre-trained model from the URFT dataset to check how the performance. And also we tried the incremental learning approach. We trained the model which was pre-trained in the URFT dataset on the CMD fault dataset. So even in this, I used I will try different approaches for 50 frames and 25 frames, and also different number of data samples. One particular data, these are the results graph for those approaches. And one thing we got is around something around 62% accuracy without while introducing the new data set. Like we are trying different approaches for increasing the accuracy of that. It like when we introduced the very new data set, it since it got around something 62%, 63% accuracy. So we could see that when we eliminate the environment, it could actually work better, and in very less time it can process the images and find the classify the subject whether it is falling or not. So after that, like the reason why we choose incremental learning is like when this approach is actually implemented in some kind of system, say maybe in the hospital, like we can train it in the overnight. So the our training time takes around less than 4 to 5 minutes, less than 4 to 5 minutes. So we can train overnight. So every time we add the data samples, like it got trained, and it will actually learn in a very good manner in every day. It can predict the approach, the predict the subject better. So this was my research approach on that fall detection. So thank you for listening patiently, and if you have any questions, please feel free to ask.
Okay, thank you so much for the
Yes.
presentation. Any questions from our participants? Bharat, can you see the question in the chat?
Oh, one second. Actually, for 85% accuracy, we also tried one more approach. Like from the start, we merged URFT dataset and also CM default dataset, and we trained a neural network model from the scratch. When we trained from the scratch, it got around something around 80% accuracy. So we have uh, a large number of data samples in the CM default dataset. So we still didn't utilize the CMD dataset for full potential. So we will be trying out the full CM default dataset and see how the neural networks is training better in the future case. So as of now, since we in URFT dataset there were only 70 videos, so we could get only small number of videos. So what we did was in CM default dataset also we extracted only 70 to 80 videos and check the generalization capability of the neural network. So in future, we actually trying to we are thinking to use the whole CM default dataset. Like if we consider the whole dataset, it was around something around 8,000 sequences for including the fall and ADL other activities. So I think that would give me more accuracy on prediction. I hope I'm clear for the question. So the final output, like we can validate using, there are multiple fault detection open source data sets, and also we can use that other data set to validate our approach, since it is trained in one data set, and we introduce a new set of videos, like say for example, even we can record ourselves for trying to falling down and see whether we can whether the model is predicting correctly or not, like that. But to get a better understanding, like we use the other open source data set which we didn't use for the training purpose. So we after the training we introduced a set of, like say for example, 100 videos and newly into the system, so and try to assess how the model is performing in those 100 videos. So that's how we can make sure that the model is getting generalized in those videos. um, yes, sure. I haven't built a system. So we just I built a different kind of approaches on the data set. I have to try it out. Like, oh, if I upload a video on, I have to. I'll in future I'll build a website where we can will upload a video and try to detect the the falling activity or not, like that. Classify the motion as your, yeah.
Yeah, actually, that is what Bala has done in this stage. Actually, is the algorithm and trying to confirm the effectiveness of the algorithm, as well as trying to see if we can do incremental learning for the new data set, which means as you can see from the presentation, actually we are not just using one data set, but using the other data set. Why we use two data set? Because we actually, in the most of the research, what you will find is people, they use the same data set and doing the test. However, see, tomorrow maybe something will change. Maybe the environment will change, will be redecorated and so on. So in that case, can your trained model can still be used for identifying for false situation? Probably not. And in fact, that is not. See, Bala, can you switch to the PowerPoint slide, which we have uh, the the accuracy. I
Oh,
think that
excellent.
is the last couple of one.
uh,
Yeah, this one. Okay, can you go back to the last one?
yeah, sure.
See, uh, from this slide you can see actually if you use the same data set to do the training, you can take a look at both the 20 friend and the 50 friend situation. The valid accuracy can reach to 100%, even after 12 epoch of training. If you still remember our earlier speakers, when we do the fish tracking, we need to train 6,000 epoch. But in this case, we only need to train 12. And that is why we only needed to train something like for each of them, we need to only use 5 minutes or 10 minutes to do the training. So, but when we do the training, you can see the valid accuracy and the precision, that is 94% or 100% and so on. So this is what when you do the research, when you write a paper, you provide people lists. And the people, they will say, wow, your algorithm is so good. See, only 1.25 seconds for the training and 8 apples or 12 apples for the training, and you can reach 100% accuracy. So actually, this is coming back to Stephen. When you ask how much more data we need to get to above 85%, actually, we don't need more data. If we are training just for this data set, for this environment, then that is enough. I mean, you can see the line 180, 120, 240. That is our data set, training set size. So you can have a 180 or 120 or 240 data set size, and you can get 100%, almost 100% accuracy performance. However, people, they will not tell you what about the train model used in a real case in another environment. So that is what we did. We try to use another data set as a new environment, and if we don't do any training or we do some training, what will happen? So if you consider to use this train model to keep detecting the fault situation in the single environment, in the same environment, then you only need to train once, and you don't need to do anything. But in any case, if you think that your environment will change, or you want to use this algorithm, this methodology to train your neural network model to identify false situation in another environment or in another hospital or in another home care environment, then you need to retrain. So that is the part researchers actually will not tell you their work is not good in terms of identifying another fall detection, or like us identify fish in another tank or something like that. But in our research, we always try to see if we can increase that, we can make it happen. So that is why we reveal, actually you can see we reveal our disadvantage for you. But when we write a paper, actually we will not telling them that if you use this model to detect another environment, that will be not very good. So at the next stage, Bala, we are trying to create something like what Ishika did, to have some kind of a dashboard and upload management function. So in that case, Stephen, you can maybe, if you got, but you need to making sure that your video is can be uploaded to a third party's system. So if you upload the video about the falling, then we can try to detect, we can try to tell you whether or not this short video, like a 1 second or 2 second video, contain fall situation. If it is, then we can tell you yes or no. On the other hand, we can also provide a kind of data set upload function. So you can upload the falling data set, non-falling data set, and ask our model to retrain or incremental training the situation. And then perhaps you can download that train model in your system. In that case, you don't need to implement the training mechanism. You don't need to implement all the things that the Bala did, like finding the trash and other things. You only need to upload a bunch of 1 second or 2 second video, and then we train the model for you. You download the model and use that model in your app or in your system. So that is our goal. Of course, that's also depending on whether or not Bala will do that. If Bala is willing to do that for the next stage, then we will open this research service and the website for everyone. So that could be our next research webinar that Bala can show us how to use and other things. Yeah. Yeah, that is what Stephen says. Yes, I think that will be a good idea. Of course, I don't know. Our research group usually consider to open freely for everyone to use. But you know, training model require the CPU power, computing power, and hosting that on the Google Cloud or Amazon AWS system. So do you want to pay or contribute, maybe donate $1 or $2 so we can use the GPU to do the training? I don't know. If not, that is fine. But if yes, that will be also good. So eventually you can see if we have this kind of service to help people to training the model for the fall detection. Maybe that is a really good benefit for everyone, because if you are home care or hospital, then you can pick up some small video and upload to the system, and then you got the train model. So you don't need to spend extra time or effort on developing your own model or developing your own system to do the recognition. You just need to upload and download the model, and then use that model in your app or application. So that is good. Yeah, let's see if that will be working. Okay, yeah.
Yes.
Anyway, any other question for Bala? If not, then I'm really appreciate all of you to join our research outcome webinar, VIP Raw 2021 for day 1. And remember, tomorrow we are going to have perhaps Bala, you can
Yes.
so I would like to, I hope you can join us. Let me see what I share. Actually, I haven't shared yet. So, so tomorrow we are going to have a 3 research outcome to show to you. So in any case, if you are interested about data mining, the time series sequential data mining algorithm, our first speaker will talk about 2 algorithms we use to identify users' behavior and provide the users a recommendation for the next point of interest according to their past behavior, wandering behavior. The second one is about natural language processing. So in any case, if you are willing to know how to use natural language processing to identify the valid and the reliable n-gram and words, you can also join us here. And the other one is the virtual patient, virtual people. So you can create your own chatbot and ask your students or ask your staff to see. For example, we know how important that discrimination should not be there, and we also know that there are some kind of a sexual misconduct and all other kind of things. Actually, you can create a chatbot and let your staff, let your students, let your faculty members to talk to the chatbot to see if their talking or their actions is not good, or if their talking can effectively communicate with virtual patient or elders, so so they can get the most important information easily from different kind of personality of the virtual person or elder. So that is our third research outcome. So if you want, I hope you can join us tomorrow at the same time, 9:30 a.m. in Mountain Time on Friday. So I'm looking forward to see you tomorrow. Thank you so much for joining us, and thank you, Bala, for your great presentation, and of course also Ishkas, your great presentation. Thank you, you both. You have a nice day, nice night, a nice dream, no matter where you are. See you.